Assalamualaikum and hi everyone. We are Group 1 and today we will present our managerial statistic assignment. Next. Before we begin, let's introduce our group members. We have Ami Ikwan, Danish, Putina Marisa, Risha, and Siti Maira. And we also have Shurin. He's only our technical for this meeting. Next. For the question 1, our dataset is about restoring customer living tips. Some customer pay the usual way, while others use a new payment device at the table. The is aim to find out if there is a difference in behavior between these two groups. Next. Answer this question. For part A, we generate the output of descriptive statistic using Excel function separately for each group of our dataset. So we will get key statistics like mean, standard deviation, skewness, and more. This allows us to compare the two groups in detail. So here's the table. Next. So for the part B, from the output obtained in A, interpret the following statistic value which reveal the characteristic for each group of our dataset. So we have mean is the average tip percentage. Standard deviation is how spread out the tips are. And lastly is skewness, which is whether the data need to higher or lower tips. So here with this mean table, we can see device user leave higher average tip than user payer. We suggest the device might encourage people to tips more. Next. So from this standard deviation tables, we can see both groups are similar variation, but the user tips are a bit more consistent and spread out. Next. So here we can see coefficient of skewness. It shows both group skewness value close to 0, meaning the data is quite balanced and different in very small. So I will give to Prisha.
Thank you. Now I will be continuing for question 1C. This slide shows the formula for a 95% confidence interval, which means the mean plus or minus the critical t-value multiplied by the standard error. It helps us estimate a range where the true population mean lies. Next. On the next slide here, we apply the formula to both usual user base and the new user device groups. Using the mean, standard deviation, and sample size, we calculate the standard error, then multiply it with the t-critical value. This gives us the lower and upper bounds for both the groups here. Next. So from the results and interpretations, the confidence interval for each group shows the range of their true tipping percentage. If the intervals overlap, the difference is not significant. But if they are far apart from one another, it suggests device user tips differently from the usual way. Next. Moving forward with question 1D, at 5% significance level, show the procedure for the hypothesis testing two samples. So the dataset A is already given. Next. This slide shows the formula for the t-statistics. It's the difference between the two groups' means divided by the standard error. In simple terms, it tells us how many standard errors apart the two averages are. A bigger t-value means stronger evidence and the device users and usual users tips differently. Next. Step 1 is setting up the hypothesis. The null hypothesis says device users do not leave higher tips, while the alternative says they do. Step 2 is choosing the right test. Since we are comparing two independent groups, we use a two-sample t-test at a 5% significant level. Next. Step 3 is calculating the test statistics using the formula. We take the difference between the two group means and divide it by the standard error. It gives us a t-value which shows how far apart the two means are in terms of standard errors. Next. Step 4 is making the decision. We compare the calculated t-value with the critical t-value at the 5% level. A graph is given here for reference. If our t-value is greater, it falls in the rejection region. Step 5 is the conclusion. If the null hypothesis is rejected, we conclude there is enough evidence that the new device users leave larger tips than those who pay in the usual way. Now I will pass it to Umar.
Okay. Hi everyone, I am Umaira. Today I'll be explaining about question 2A and B. So based on our understanding of the question, the company is concerned that older machines might be becoming less reliable and cost more to maintain. So to help decide whether or not to replace them, they collected data on 100 welding machines, recording the age of each machine in months and the monthly cost of repairs for each one. So our goal is to test whether there's a linear relationship between these two variables. To perform this analysis, we define dependent variable as y, monthly cost of repair, and X, independent variable, for age of the machine in months. Why? Because we are trying to see if the cost of repairs depends on the machine's age. So for 2B, after we key in the Excel, we managed to get 3 tables, which are regression statistics, ANOVA, and the third table. While our model is statistically significant, the relationship between age and repair cost is weak. So the negative slope is also counterintuitive, possibly suggesting that newer machines are costing more due to other issues such as high maintenance fees. Only 8% of the cost variation is explained by age. Hence, the company shouldn't rely on age to make decisions about replacing machines. So I'll pass it down to Marisa.
Okay, thank you so much, Umaira. So I'll be continuing the C question. Determine the estimated regression equation from output B and interpret the coefficient. So the original equation is the one with epsilon. So however, since our epsilon or our random error is assumed to be 0, so our equation is simplified to be y hat equals to 358.7688 plus, minus 0.7581x. So our interpretation would be B naught equals to 358.7688. The monthly cost of repairs is 358.7688 units when the age of the machine is 0 months, and our B1 is negative 0.7581. For every additional 1 month of the age of machines, the monthly cost of repairs will decrease by 0.7581. So next. So D, determine the coefficient of correlation from output B and interpret the value. So from the regression statistics that we have generated, we got the multiple R is equals to negative 0.2835. So the interpretation is it shows a weak and negative correlation between age of machines and monthly cost of repairs. The negative sign is consistent with the negative B1 of the regression equation. So however, because of this correlation is weak, the relationship is not strong, which means other factor may have more influence on repairs cost besides just the machine age. Next. E, determine the coefficient of determination from output B and interpret the value. So from the summary output, we have R squared, which is 0.0803, which also equivalent to 8.03%. So that is 8.03% of total variation in the monthly cost of repairs and is explained by the variation of in the age of machine. So the balance of 91.97%, which is 100% minus by our R squared, is the unexplained variation. So I'll pass to Ami.
Thank you, Marisa. So I'm gonna present the F and G. So for the first question is, can we infer that dependent variable has a significant association with the independent variable? So in completing this calculation, we got three steps to complete the answer. So for the first step is we should find the hypothesis statement. So we got here that HO beta 1 equal to 0, which is no significant linear relationship and that's it in value. And the second one is H1 B1 in equal to 0, which is a significant linear relationship and its value. So move to the next step is step 2, evaluate the test statistic, and I'm sorry, I'm still in step 2. So first we should find the alpha, which is 0.05, which is not given, and we need to get the 0.05, and the value we got from the ANOVA table, which is 0.0043, and we can see here 0.0043 less than 0.005, which means the value less than alpha. Then next, step 3, decision and conclusion. Note that p-value less than alpha, we will reject HO. Then for the second condition, p-value greater than or equal to alpha, do not reject HO. For this condition of the answer, we got p-value less than alpha. So reject HO, the model is valid and there is strong evidence of significant linear relationship between the age of machine and monthly cost of repairs. So there is significant association between the age of machine and monthly cost of repair. Next. Let's move to the scatter plot graph. So we here to discuss the relationship of the variable based on the pattern of the straight line of the scatter plot. Here is scatter plot graph. We already run the scatter plot graph with the dataset in the Excel, and you can refer to our Excel sheet for more detail about scatter plot. So next, so how we interpret the scatter plot graph is next. Okay, this how we read the scatter plot. There appears to be weak negative linear relationship between the age of machine and the monthly cost of repair. This means the older the age of a machine, the lower monthly cost of repair. There is no visible pattern of nonlinear relationship. Hence, a linear model is suitable to reflect relationship between the age of a machine and the monthly cost of repair. So that's it. That the relationship also appears to be weak as the data reveals a widely scattered and unpredictable pattern, which explain all this small portion of the variation. Okay, next. So that's all from us right now.